Problem 7. I need to calculate the value of load resistance to get maximum power at load. I also need to find out that maximum power at load. I am following maximum power transfer theorem. First, I need to find out open circuit voltage. So removing this load resistance, here this, keeping the rest part as it is. This is our target potential, which is VOC. To calculate this, I am considering the node voltage at here is V. Now see here, this is 2 ampere current. Here this point and this point are same point. So using KCL at this point, 2 ampere is inlet current, which is summation of this current, say I1, this point at this point same point, this current say I2, and this current say I3. So using KCL at this node, this 2 ampere is equal to I1 plus I2 plus I3. So what is I1? Here the potential, at this point potential is V, and at this point the potential is potential drop across this 1 ohm. So I have mentioned here as V 1 ohm. What is I1? I1 is the potential difference across this 10 ohm resistance, which is V minus V 1 ohm. So I1 is equal to V minus V1 divided by 10. This one, V minus V1 ohm divided by 10. Next, I2. What is I2? I2 is the current flowing through this path. Mainly the difference between these 2 points is V minus V1 ohm. Again, here is certain potential, that is 20 volt. So ultimately the potential for this I2 is V minus V1 ohm minus this 20 volt. So that potential divided by this 2 ohm is equal to I2. Say this one. Next, I3. I3 is flowing in this direction. At this point the potential is VOC. So I3 is V minus VOC divided by 5 ohm. So this I1 plus I2 plus I3 is equal to 2 ohm. Simplifying this equation, I got this relation. Now here, what is V1 ohm? V1 ohm is equal to current multiplied by this 1 ohm. What is current through this 1 ohm? See, this current is flowing in this path, and here a current source is 5 ampere. So the 5 ampere is flowing through this 1 ohm. So V1 ohm is equal to 5 ampere multiplied by this 1, that is 5 into 1, that is 5 volt. So V1 is equal to 5 volt. Now putting this 5 volt in this equation, I got this one. See here, V1 ohm is equal to 5 volt. Ultimately I got the relation 0.8 V minus 0.2 VOC is equal to 15. This is equation number 1. Now using this node, here in this direction, one current is coming out from this node. This is inlet current. Another current is in this direction. So using this node, this current will be equal to sum of this current plus this current. So this is I1, this is I2. Now value of I1 is for 2 ampere. But what is I2? I2 is equal to this VOC, this point at same point, VOC minus V divided by 5. So VOC minus V divided by 5, this is I2, and I1 is equal to 2, which is equal to inlet current 5. Using this relation, I got this equation, which is equation number 2. Two variables, V and VOC, here also V and VOC. By solving these two equations, I got VOC is equal to 45 volt. If you face any problem to make it clear, just pause the video and try to understand. Now to find RTH, open this load resistance. Say this is open, current source is open, here C open, this current source is open, C open, this voltage source is short. So ultimately this is the combination of resistances to get this RTH. Now if you feel any difficulty to understand which one is in series or in parallel, redraw the circuit in simpler way. Say at point, this is point A, this is point B, start working from A. So this is A, is having single path 5, this is 5 ohm. Next two paths, this is one path, this is another path, 10 and 2. One is 10 ohm, another one is 2 ohm. This meets at a particular point. From here 1 ohm, and ultimately I got B. Now from here it is easy to understand that 10 and 2 are in parallel. Say first equivalent of this in series with 1 and 5, and ultimately I got 7.6 ohm, which is RTH. Now this is equivalent Thevenin circuit. BTH is equal to 50.54, RTH is equal to 7.67. To get maximum power at load resistance should be equal to RTH, that is 7.67, and using this equation to get maximum power, I got maximum power is 66 watt. Now checking whether my calculation is perfect or not. This BTH, RTH, load resistance is equal, and here in main circuit I have used load resistance is same as 7.67 ohm. If I get power in the main circuit and equivalent circuit equals with 66 watt, then it can be certain that my calculation is perfect. So running the simulation, say here it is showing 66 watt, in main circuit also showing 66 watt. So out of the calculation I did to solve this problem, it is perfectly okay.